Right on you, right. I'm going to take you through the I Can Do measurement assignment or learning assessment. Now, and I'm just going to do the perimeter part. In this assessment, the reason we do this assessment is so that you can show us your level of understanding. So you are going to show us your understanding by doing it. That's why it's an I can do. Now you can make up one or more examples in each of these questions that show that you can do what's been asked. You will need to show diagrams, but they don't need to be to scale. Righto. So the first question here says, I understand and I can convert units of length from big to small. And there's specific in what units we want you to convert them from. Now I've done two examples here. I've done A and C because one's converting a big to small and one's converting a small to big. In the first example I've done, here I've written the question, convert 5 centimetres to centimetres. And I write 5 metres, 5 times 100, 500 centimetres. That's a good example. But this is a better one. If I look at this one, convert 2.1. So straight away it's a little bit harder because it has a decimal. It's not a lot harder and there's not much else you need to do, but it's a little bit harder. And then I show my solution. So that's a little bit better, not a whole lot. Over here, convert 80 millimetres to centimetres. Well, this is a good example. 80 millimetres, I divide by 10 and I get 8 centimetres. Nice and easy. Good example. Shows the understanding that to convert small to big, you've got to divide. But this one's a little bit better. Why? Because it's 0.87, and that's a little bit more difficult to deal with. Some people don't understand that it's just a number and you're still going to divide by 7, but by 10, sorry, but you get the same answer. So, not the same answer, but you get the correct answer. So that's just a little bit better. And there are two ways you can make it a little bit better. Okay, here we go. I can calculate the perimeter of a triangle given all sides. So there's your clue. You've got to draw or give a triangle and say, find the perimeter of this. So here's a good example of one. Find the perimeter of this shape here. Well, this is a nice easy right angled triangle, 5, 12 and 13. You'll note that it's not to scale. It's reasonably close, but it's not to scale. So 5, perimeter, here's my solution, perimeter equals 5 plus 12 plus 13, 30 centimetres. That's a good example. Shows that you understand how to find the perimeter of the triangle by adding the 3 sides. This one, however, find the perimeter of this shape is a little bit better. Why? Well, for a start, it's got one measurement that is different. It's in millimetres. This one's in centimetres, this one's in centimetres. So I need to convert that, and I probably should have shown this, by dividing by 10, and that becomes 3.5. And then I add 3.5, 3 and 4, and get 10.5. So that one's a little bit better because it shows that, not only do you know how to calculate the perimeter, but you know how to calculate the perimeter if one of the sides is not in the same units as the other two. Now, this is where you have to be particularly careful because sometimes you can do something that is wrong. So, say for example, if you drew a triangle like this and said, find the perimeter of that, you cannot draw that triangle. It does not exist. Watch. If I have a line that's 8 centimetres long as my base, and then I draw a line of 4 centimetres, and I draw a line of 3 centimetres, well, 4 plus 3 equals 7. Even if I lie those two lines flat, they won't meet. There's no way they're going to meet up there because they're too short. If the two short sides do not add up to the long side or more than the long side, then you can't have a triangle. So be very careful when you make your questions up. Either look at a textbook and find some examples, or check with your teacher or mum and dad or brothers and sisters to see if what you've written makes sense. Okay, the rectangle. Well, this is pretty easy. Find the perimeter of a rectangle given two adjacent sides. Here's a good example. Find the perimeter of this rectangle. It's got sides of 2 and 4. So because it's a rectangle, that's 2, and that's 4. And my perimeter is 2 plus 2 plus 4 plus 4, 12. Good example. Well done. This is a better example because in this question, there's no diagram. The diagram is in the solution. Find the perimeter of a rectangle with sides 3.2 and 300. Well, not only is it good in that it doesn't provide a diagram, the diagram has to be drawn, but I've got a unit in meters and I've got a unit in kilometers. And you can see here, I've done the 2 conversions. I've divided by 1,000 and I've multiplied by 1,000. So I actually get 2 solutions. I can get the solution in kilometers or I can get the solution in meters. If I take the solution in kilometers, it's 3.2, 3.2, 0.3, 0.3, 7. If I take the solution in meters, 3,200, 3,200, 300, 300, 7,000 meters. So that shows a higher understanding of perimeter and measurement because of all those reasons. All those reasons, converting, getting 2 different solutions. Well, they're not different, they're the same, but they're in different units. And it shows us that you know exactly what you're talking about. Here we go. I can find the circumference of a circle given the diameter. Again, I write the question. Find the circumference of that figure. There's the diameter, pi times d. But this one doesn't give the diagram, it just gives a question. The diagram is in the solution. And it also has 2.1. It's a decimal. So that's a better one. This is good, the first one, but the second one is better. Hopefully you can do 5 on your own. Note it says given the radius. Right? You have to give the radius, you don't give the diameter. Number 6, I can calculate the perimeter of a sector. And look at this is specific. It says for an angle between 90 and 120. And when I first did this, I made the mistake. I did too big an angle. So here's my question. Find the perimeter of the figure below. And I've drawn a sector of a circle that has 110 degrees and a radius of 7. The first thing I do is I find the diameter. And then I go, well, the perimeter is this and this, 7 plus 7 plus this bit. How much of a circle is that? It's 110 of 360 times pi times the diameter. And remember, the diameter is 14. So that is a good example. Now, I haven't done another one, but can you think of a better example? Here's an idea. Maybe write the angle in degrees, minutes, and seconds. That shows a higher level of difficulty. All right, the last one. Now, this took me some time and will take you some time. So you need a composite shape. Now, a composite shape is a shape that is made up of parts of other shapes. All right, so you can see here, I've got a rectangle, a semicircle, and a triangle. You don't have to have that many, and you can have whatever you want. But look at this. The perimeter must be between 50 and 60, and this took me a couple of goes. So, and your shape has to make sense. So you'll notice in my triangle here, that's 7, and I've got 5 and 5. 5 and 5 is 10. It's greater than 7. I know it can work. This is 15 and 7, so I know that my shape works. So there's my question, and off I go. So my perimeter is 5 and 5, 15 and 15, and then this much of a circle, which is a half, and it's pi times the diameter. And I had to do this a couple of times to make it work, and you can see I just got 50.99557429, which I rounded to 51 centimetres. Now that shows a lot of understanding because I've got triangles or parts of a triangle, I've got a semicircle, I've got a rectangle. You can do all sorts of things. Right? You could do a field, you could do a rectangle like this. like a athletics track. You can do anyone's. You can use you could do something like this. You could just do a nice easy one with a square with a triangle on top, although you wouldn't include that. So whatever you do, it's up to you, but you need to make it sure that it works. So be careful to make sure that it works and the shape you make exists and can be constructed. And I'd suggest in this one, don't make it too hard. Yes, if you've got lots of time and you want to really experiment, do an easy one. Do a nice easy one so that you can show us that we understand. So do a nice easy one, which could be a square with just a triangle. Or, I don't know, a triangle with a semicircle, like an ice cream cone. Something nice and easy like that. And once you've got that done, if you want to go and try and be really outlandish, then try something else. Anyway, good luck with that. Remember, this is how we're going to assess your understanding of perimeter. And you can see straight away, it's a good way for us to see if you know what you're talking about. Anyway, good luck, year 8.